My name is Chandra Wickramasinghe. I started off as a mathematician and then went into astrophysics and into astrochemistry and finally astrobiology. I was born in Sri Lanka, which is my birthplace and my home. 1939 was a British colony, and at the time when it was believed that empires lasted forever, I was in that one of those countries that was being ruled by the British. Well, through my early life, empires vanished like morning dew, and Sri Lanka became Ceylon, which is Sri Lanka now. It is an independent country. So that's where I was born. And much of my early impressions of the world around me was essentially based on my upbringing in that tropical island, in the beautiful tropical island. I went to university there and studied mathematics. I got a first-class honors degree in mathematics. And on account of my performance in that examination, I was awarded what was called a Commonwealth Scholarship to go to Cambridge to do further studies. Started my long career in astronomy research, in astronomy, astrophysics, and finally astrobiology. So this is a research and teaching career now that has spanned some 45 years. And you asked how many jobs I held. I was, to begin with, I was a teaching fellow at Jesus College, Cambridge, one of the oldest colleges in the University of Cambridge. Between 1963 and 73, I was at Cambridge as a fellow of Jesus College, and also as a founder member of the Institute of Astronomy, which was started in Cambridge University by the late Sir Fred Hoyle. So it is with, and also I think I should mention that it is my connection with Fred Hoyle that essentially led me into the kind of areas that I subsequently researched and worked on. I was in 1973 the youngest professor that was appointed at the university in Cardiff as a professor of applied mathematics and astronomy. I was supposed to start a new activity in Cardiff, Cardiff, UK, that's in Wales, in astronomy, and I set out to do that. I collected a team of colleagues around me, and we had quite a thriving activity in astronomy between 1973 and about 2000. And there, at that time, there was a change of administration of the university in Cardiff, and things were getting more and more difficult to continue. So I ended up sort of a 5-year period there as a director, setting up a new center for astrobiology called the Cardiff Center for Astrobiology. And I reckon that is the first ever center for astrobiology in the world. I mean, it's not talked about as such because other people have taken credit for starting astrobiology. But in fact, astrobiology was a discipline that was, and I say this unabashedly, was invented by me and the late Sir Fred Hoyle. We coined that name. We published a paper in which it said that the time has come for astronomy to merge with biology because the two subjects are inextricably intertwined. From our research in the 1980s, it was becoming clear. So we take credit for the essentially for the start of astrobiology. And I think your listeners, some of your listeners would not like it because they think that the Americans invented astrobiology. Not true at all. They invented a subject called exobiology, the study of possible living processes that might lead to life in the universe. And that was going on for quite a long time. And at the time that I started working on these matters, it was turning out to be a rather fallow field. There was nothing happening. So astrobiology came in as a result of the failure of exobiology. Well, you next asked me what made me interested in space and astronomy. The answer is quite a complicated answer. And as I told you, I grew up in Sri Lanka at a time when the night skies were really brilliant in the place where I grew up, in my home in Colombo, just outside of the center of Colombo. Night after night, I would see the glorious spectacle of the night sky. And that was essentially in my sort of early, when I was 12, 13, 14, those were the night skies that really triggered my interest. And then I was getting sort of interested in mathematics as a subject to study at school, and I was good at it. And so I began to read a lot about maths and physics and so on. And one event that really turned me firmly towards astronomy was an eclipse of the sun, a total eclipse of the sun in 1953. And these are not particularly rare events, but it was in the visibility was supposedly best in Sri Lanka, in Colombo. And my home country was then, for about a week, the focus of a lot of international scientific activity. There were scientists from all over the world, from the US, from England, from Japan, who converged on Ceylon and with ambitions to try to do things around the eclipse. So that was a trigger that made me read more about astronomy and get more deeply interested in astronomy. But I should also mention another personal aspect of my career, which is that my father, who was a mathematician himself, he was trained in Cambridge in he got the highest honors in Cambridge in mathematics at Trinity College, Cambridge in 1933. He was what they call a B-star wrangler and a senior scholar in Trinity College. And he was a pupil of the late Sir Arthur Eddington, who was essentially one of the pioneer astronomers of the early decades of the 20th century. So there were lots of books in my home on really quite difficult books. I couldn't even dream of understanding them in my teens, but it was all around me. Mm-hmm. And also my father, having studied astronomy at Cambridge, I had some really stimulating conversations with him about this Milky Way, about the stars, and so on. So that was my my backdrop. And when I went to Cambridge, of course, I didn't really know what I was going to do for a research career. So I had a conversation with Sir Fred Hoyle, who was the top astronomer in Cambridge at the time. He directed me first to a problem in solar physics, right? Mm-hmm. On how the magnetic field of the sun switches periodically. And I was put to try to figure out how that happened. Mm-hmm. So I'd spent about 8 months working on that, and we published a paper. But it didn't really excite me that much. The solar physics was not a particularly exciting field for me. So when I went back and asked Fred Hoyle, what should I do next? He suggested that I looked into the nature of cosmic dust, which in 1962 was again seemed to be a rather fallow field. Very few people were working on it, were interested in it. But there was an established position as to what this dust in space was made of. Now, I should tell you that the dust in space is very clearly seen in the Milky Way on a dark night. You can see the stars arching across the galaxy, and in between the stars, you always see huge numbers of large clouds and striations and shapes and so on, right? These are the interstellar clouds. And so it's been a puzzle for maybe 2 decades before I ever started working on it, to try to figure out what the cause of this obscuration is. What is the material that is causing these dark patches? And there was an orthodoxy in place at the time when I started looking at this. And the orthodoxy was that there were tiny crystals of ice, myriads, and millions, and billions, and trillions of tiny crystals of ice, rather like the ice crystals that you see in the cumulus clouds of the Earth's upper atmosphere. If you look up in the clouds, you see these white, great big white clouds, rain clouds, and so on. And they are a lot of water vapor condensed around little particles of ice, right? Tiny crystals of ice. So astronomers thought that the ice crystals were really present everywhere in the galaxy, and that was the end of the story. So when I then started looking at the evidence for that, mathematically, scientifically, and from studying the astronomical data, it seemed to me that this is totally untenable. The ice grain model, I decided in 1961, is totally wrong, right? And what I then found through my studies was that far more plausible is that there are these tiny particles of interstellar dust are made mainly of the element carbon, right? Carbon, I thought originally that the carbon was in the form of like particles of soot, right? Not very interesting, but carbon, of course, is the main component, it's the most important chemical element in living things. So I then, in 1962, published a paper saying the interstellar dust was mainly comprised of carbon, probably made of soot-like particles, right? Trillions and trillions of these. And the total mass of this stuff is just enormous. It is almost the mass of the stars in the galaxy. So it's not a trivial amount of matter. There's as much material in the dust that is in the black and dark clouds as in stars. Right? So this is a very important part of our world, and it was very poorly understood. So I set out then to go deeper and deeper and to try to understand what that carbon really, how that carbon comes to be there and what form it is in. I suggested the carbon as graphite or soot, and that was initially, of course, fiercely resisted by American astronomers, by Dutch astronomers, and so on. So I used to go to conferences and present this argument and present the case for carbon dust, and a whole avalanche of scientists came against me. But then what happened was really interesting, because sort of space exploration was beginning to take off in the mid-1960s. Balloons, at least to begin with, balloons were sent to the stratosphere with instruments to study the light from stars. And the first such measurements of the properties of the dust showed that the carbon was indeed the main component of the dust. So hooray, I've been proved right. And all these other guys had were really had egg on their faces, and they tried to recover in various ways, but they just couldn't. So after about a 3 or 4 year debate with leading astronomers, people finally agreed that carbon was an important component. And so this was the step 1 towards astrobiology. Step 2 was also taken by me and my collaborator, Fred Hoyle, and a few other students. We discovered that there were astronomical spectra that were showing the presence of fairly complex organic molecules in, not dust, but molecules, right? Combinations of atoms in the dust clouds of space. And my analysis of these, early analysis of these, showed that there were molecules like double ring molecules, like biological molecules, and so on. And we published a lot of papers in Nature to say that the beginnings of biology, beginnings of life, seem to be taking place out there in deep space, right? And these, of course, got published and reviewed and so on. But again, there were fierce arguments. Guys even like Carl Sagan, whom I greatly admire and respect, published a rebuttal saying that, well, this is very interesting stuff that Chandra and Fred are publishing, but surely organic molecules cannot survive the very harsh conditions that are there out in space, right? So this kind of argument and debate was going on for a little while. And by the late 1970s, I was trying to figure out how so much of lifelike organic molecules were out there. Organic dust was out there. And it occurred to me that if you look at what's happening on the Earth, right, you've got the ground, you've got the soil, there are lots and lots of organic molecules. And those organic molecules are made from living processes, right? They are mostly the decay products of bacteria and viruses maybe, but they are biological, definitely. There's no other process that one thinks of that is responsible for the vast amount of organic material that is here on the Earth. So I posed the question to myself, why not the same in the universe around us? Why is it not possible to argue that these vast quantities of organic molecules are really the result of a life process? Now that was a radical departure from current thinking at the time in the 1970s. So I encountered a lot of fierce rebuttals and arguments and so on. But I pursued because I thought that was the only reasonable way in which I could begin to understand the data that was slowly emerging in space to show that there was all this dust in space. So the next step was to try to make various predictions. If these molecules, these complex chemicals are coming from life processes like they do on the Earth, how do we test it? And so we said that let's assume that all the dust or most of the dust in space, the carbon dust that we talked about, is actually bacteria and viruses, right? Because bacteria and viruses are very, very easy to multiply and replicate, as we know here on the Earth. Given the right conditions, one bacterium becomes 2 in a matter of a couple of hours, and the 2 becomes 4, and so on. And soon one bacterium could multiply and make up the whole universe, if you like, right, within a short time scale. So the multiplication, the replication of bacteria was something that really stuck in my head as being a very important piece of evidence. So I said, and this is me and my colleague, Fred Hoyle, we said that let's assume that the dust in space is largely made of bacteria in various stages of degradation and decay, right? And how would we predict what would be the outcome of such a statement? So we made a prediction that if you looked through all the dust clouds at a very, very distant source of infrared light in the galaxy, in our Milky Way, you would get a signature of the bacterium, right? In other words, if you look at a street light through a fog, you have the properties of the fog showing up in the light that you pick up at the end of the, you photograph it, and you can infer that there is a certain material between the street light and you. In a similar way, we argued that the light from this very, very distant star going through all the muck and the debris and the stuff, if they were largely bacteria, should end up on the Earth through the telescopes of the Earth and show what's called a spectroscopic signature of a bacterium, right? So I was in Cardiff at the time, and I had moved from Cambridge to Cardiff in 1973. And so I had a research student that I put on the job of trying to take bacteria in the laboratory and shine a light like a starlight through it and find out the result, what kind of picture or image, spectrum, as they call it, comes out of the bacteria, the light that goes through the bacterium. So we had a certain pattern, and then we had to ask some astronomers to do the same thing in astronomy, in deep space. So we suggested to the guys in Edinburgh and London, and they said, we are not going to waste our time on this crazy project. So nobody did that in the UK. We didn't go to the US, but fortunately for me, but it's just an accident, I had a younger brother who was an astronomer, and he was the head of the mathematics department at the Australian National University. He had access to the biggest telescope at the time, which was the Anglo-Australian telescope, and we persuaded him to carry out these experiments. So he did this, and lo and behold, we found the pattern of light that went through all the dust in space was exactly like the pattern of light that we found in the laboratory that goes through a cloud of bacteria. So perfect was this match that it was almost, I mean, at this point, both Fred Hoyle and I said that was it. We have made a prediction, a very precise prediction, and that has been verified. And so we have to assume that there is a vast amount of living material in varying states. They need not all be living, of course. Part of it might have decayed and dried out and so on. But they all start off as living bacteria. And this material is present in vast quantities in the space between stars. So that was a really stunning conclusion. So we were able to publish a few papers. Up to that time, we were publishing these arguments and so on, unabashedly in the most read journals of the time, like Nature, right? And we had them published, and we had rebuttals, of course, as I said, like from Carl Sagan. But now, when we said that this evidence for the bacteria is 100%, they began to run a mile. They didn't like the idea of their journal being tarnished with some heresy that was so wildly outrageous. So we then had to resort to other means. We found another journal that was able to accept it, called, we had a friend who was editor, Professor Kopal in Manchester, was editor-in-chief of a journal called Astrophysics and Space Science, and we got some of these papers published there. And we also started a preprint series to mail to hundreds of colleagues, right? And this was like the Russian Samizdat press, when the Russians were being heavily censored in the communist era. They had this press called the Samizdat press. So we had this, and our colleagues teased us that this was a Samizdat operation. But we got the message across all right. And so it continued like this. We collected more and more evidence for signatures, precise signatures of living material being reproduced in the material between stars. In 1980s, there's another question that we had to ask at that time was, how is this material being produced and present in such vast quantities in the space between stars? Because after all, the total weight, total mass of this dust, lifelike dust, is almost equal to the mass of the stars, or a very large fraction of the mass of stars. So how is this possible? And the answer that we came after a lot of consideration was that it was essentially being replicated. This material, the bacteria, was being replicated in the deep interiors of comets, right? comets at the time were thought to be dirty snowballs. So again, it was a big heresy to say that the comets had a lot of organic material and that they had liquid water domains and so on. So this was an outrageous heresy from cometary science point of view, but we published books and papers and so on with the title Living Comets and in the 1980s, okay? 1986, we have a stroke of luck. Comet Halley, a historic comet, that's Halley's comet, reappears in the space age. Now, at this time, this is the first comet that was accessible to space exploration. By the early 1980s, we had suggested that comets are the source of the dust in space, that comets are the main supply of the vast quantity of biological material, bacteria and so on, in space that we had already discovered was consistent with the astronomical observations, okay? So we had then to decide how could we test that proposition? How could we test that comets are, in fact, the source of living material? Now, comets have in the past, throughout history, been feared by almost all ancient cultures as the bringers of pestilence and death. So trying to say that comets carry bacteria was again a huge, huge heresy that people didn't like to have revived. Anyway, we looked at all the evidence and it seemed to be consistent with this possibility, with this rather outrageous possibility. And in 1986, a rather important event occurred. Halley's comet reappeared, the very famous Halley's comet reappeared, and there were space explorations that were planned for it. There was, for instance, a mission, a European Space Agency mission called the Rosetta mission, which was supposed to fly almost close to the comet and for the first time ever to try to photograph the comet, to get a picture of what the comet nucleus was like. Because up to that time, comets were seen as just sort of huge streams of light that came out from an unknown point source, and it was not really clear what that source of all this huge tail of material was, really, in terms of its structure and so forth. And it was presumed that, just like in the case of the cosmic dust, it was presumed that this was just a ball of ice, right? It was a dirty snowball, was the model of the comet in 1986 that every astronomer thought was 100% proven. And we had by then published papers saying that, no, this cannot be true. The comets are the source of all the living dust in space and so on. So it had better be an organic comet. And an organic comet wouldn't look like a dirty snowball, right? So the cameras went close to the day of reckoning, close to the comet. The spacecraft had huge cameras. They had decided that it was an ice field, a field of ice and field of snow that they were photographing. So they essentially closed the aperture of the camera to almost nothing, right? In the old cameras, you can adjust your aperture. If there's a lot of light, if you're photographing a snow field, you make the aperture very small. So they did that for the comet, for Comet Halley. And on the night in question, when all the international television stations were reporting it, I was watching this with bated breath. The message was, no, we've lost the comet. It looks like the spacecraft has missed the comet completely, because they could not photograph anything. And we had predicted that this comet would be as black as pitch, and therefore what they found was exactly what we expected. If you really cut your aperture to nothing, expecting a snowfield, and you try to photograph a very dark surface, you wouldn't get anything. So that happened, and then it took many weeks after the event for them to essentially go through all the images, the Rosetta mission images, and use image enhancement and so on. And then they eventually got an image of the comet, which was as dark as pitch, right? So this was another triumph for our theory. although people didn't recognize it as such, of course. So it went on like that. And then for this Halley's comet in 1986, there was yet another observation, which was made again by my brother in Australia and David Allen, two astronomers. They did what he called a spectrum of the dust that came out of the comet. And the spectrum of that dust, again, matched 100% the spectrum of a desiccated bacterium. Just amazing, right?
Yeah.
So now we have two observations, the dust looking like bacteria in space and the dust from a comet looking like bacteria also. The rivals, contestants to this idea of cosmic life, then had to work out a strategy. What they began to argue was that, okay, these things look like bacteria, but they're not bacteria. They're just mixtures of organic molecules that are just formed naturally. Nobody tells how they were formed, but they were formed, and they have got together and they just mimic the properties of a bacterium. Now, if you believe that, you believe in fairies in the back of your garden. But that belief was deeply entrenched for about, I don't know, for almost up to the present time. Right? More and more evidence has come for bacteria in deep space that it is becoming very, very difficult for, I think, for science to proceed if they have such a strong aversion to respecting facts for what they are.
Why don't they want to believe it then, do you think, John?
I think it is because the belief and the fixed idea that is in every scientist's mind is that life started here on the earth in a primordial soup, right? Life is essentially centered on the earth. And so to have life everywhere in the universe is essentially a big, big problem. Now, the idea of life starting on the earth in a process that has come to be called abiogenesis or spontaneous generation goes back a long time. It goes back to Aristotle, the Greek philosopher of the 3rd century before Christ. Aristotle argued that if you take a mixture of warm earth and morning dew, you can make life. You can make fireflies, right? And this idea of just life turning up from mixtures of organic molecules or non-living molecules on the earth became orthodoxy in science, partly because in the early Roman Empire, when it became Christianized, right, the Christian orthodoxy also regarded Aristotle as being their guru. Aristotelian philosophy was very convenient for the papacy to argue that life was centered on the earth. Life started on the earth by some divine act, that the earth is the center of the universe. And this is again an Aristotelian idea, that the earth is the center of everything, of the center of the universe. So two ideas of Aristotle. One, that life is centered on the earth. Life started on the earth by spontaneous generation. And that the earth is the center of all things, became deeply connected with theology, with religious Christian philosophy. So I think that has been a problem for a long, long time. Now, it was very difficult to maintain the idea that the earth is the center of the universe after astronomers began to find evidence for it not being so. So again, to get from an earth-centered solar system to what we have now, the heliocentric model, the sun-centered solar system, was a long, long struggle. It took about 200 years of fighting the orthodoxy, of fighting the papacy, to essentially, from Galileo to Copernicus to Kepler to Newton. It took all these people and discoveries over about 150 years before the final concession was made. And then the church had to concede that maybe the earth is not the center of the world, and so on. So that was done. But the story of life being at the center of the universe was very difficult to shift in the same way, because the evidence was not that direct, right? The evidence that we have also produced was seen to be equivocal, to be arguable. And so I think that is the main reason. But if you turn the clock back 200 years before Aristotle, right, you come to a Greek philosopher called Anaxagoras, a pre-Socratic Greek philosopher, Anaxagoras, who argued that life has to be everywhere in the universe. And he invented, essentially, in the Western context, he invented panspermia, the idea of panspermia. Pans meaning everywhere, spanning everything, and spermata meaning seeds. So panspermia meaning seeds everywhere in the cosmos, taking root whenever the conditions became favorable. Right, so that's the European beginning of panspermia, but that's not the absolute beginning. It goes back even further. If you go back to Vedic traditions of ancient India, the idea that life is universal is deeply connected with ancient Vedic philosophy. So I think you asked me the question, why is it resisted? Why is the idea of life everywhere being resisted? I think it is largely religious, cultural, and habit of thinking. I think we really still like to think of ourselves as being perhaps the most important entities in the world, and to be demoted from that position to being just another trivial outpost of life. The Earth is just one of billions of other planets that have taken on the bits and pieces of cosmic life that are floating everywhere in space and through comets and so on. To think that, to accept that is really, really hard, psychologically hard. But hard though it may be, I think facts have to be faced. Otherwise, in the long term, we don't make progress. The only way that we make progress in the world is to accept facts for what they are. And at the moment, I think we are in a situation of really desperate stalemate. We have evidence that has accumulated not just from the interstellar dust, that was the first starting point, interstellar dust, the comets in 1986. Then there were recent missions to comets that, again, the Rosetta mission and so on, they show consistency, 100% consistency with life, with biology being present. But nobody has dared to do a life detection experiment on a comet. Well, comets have since been studied in several missions. There was the Stardust mission, in NASA Stardust mission. Most recently, there was the European Space Agency's Rosetta mission. And I happen to be one of the original science team of the Rosetta mission from Cardiff. And myself and my colleagues in Cardiff had suggested a very simple life detection experiment to put on the surface of comet the comet that was being examined by the Rosetta mission, comet CG67P. It's called C-G67P is the short name for the comet. And so we made this proposal. And in the earliest meetings of the science committee, it was decided this was crazy, and they just took it out. Although the proposal itself, the costing of the proposal was just $7,000. $7,000 to do a simple life detection experiment that would establish once and for all that there was either life on the comet or no life on the comet. So in the event, the Rosetta mission went ahead. In the last 5 or 6 years, there have been lots of very, very interesting data that came from the mission. all the data is 100% consistent with a living comet. There are fountains of organic material being thrown out. There's the surface of the material of the comet matches again the properties of a bacterium and so on, all indirect. Unfortunately, because there was no life detection experiment, it is still possible for the skeptic to say, maybe these things look like life, but they're not really life. It cannot be life because life has to be confined to the Earth. So this is the kind of stalemate that we have at the moment. Evidence is mounting almost in every direction that life is a truly cosmic phenomenon, that panspermia, the idea that goes back to Vedic times, the idea that was essentially enunciated in a very precise form by the Greek philosopher Anaxagoras, is 100% correct. From an astronomical point of view, study of comets, study of interstellar dust, there is no doubt at all in my mind that life is everywhere, that the interstellar medium is full of bacterial particles. Comets are essentially the source of the biology that you see everywhere in the universe. So what is the model then that we have? We have a model in which life is being carried right through the universe in the form of bacteria and viruses in comets. And whenever comets land on a planet that is habitable, like the Earth, then the living process takes off. You have bacteria first being deposited on the Earth, and the oldest evidence for bacteria on the Earth is at 4.2 billion years ago in the so-called Hadean epoch, which was an epoch of hell, so-called epoch of hell, where comets and asteroids were relentlessly pounding its surface. You have the first evidence of fossilized bacteria. Then, through a long period of several billion years, you have the processes by which life becomes more and more complex, ending up with the enormous range of life, the varied life forms that we find here on our planet. So every bit of biological evidence, geological evidence points to the fact that this whole process was essentially controlled by bacteria and viruses coming from space, viruses being introduced as new genetic material that can bring new life forms and new traits, new species to the Earth. So that's the final situation that we have now, that the whole of the process of life on Earth, the evolution of life on Earth, is a Darwinian process, but the Darwinian process is not in the way that is usually thought, just random mistakes leading to more and more sophisticated life forms. It is the introduction of new body plans, new traits, new innovations in life coming from bacteria and being accumulated. It's like a child's jigsaw puzzle. We have all the bits of life that can make almost any species, and they're just falling on the Earth, and they're getting together and assembling into the huge panorama of life that we see here on the Earth. So that's the grand picture that's emerging. And so what are the tests that are possible in the present day? And this is very important, because if you have a theory that is as bizarre and as wild as this, you have to find ways in which you can tell people this is irrefutable. There is evidence that life is out there in space. There's evidence that life is coming to the Earth even now, here and now. Because if life came 4 billion years ago, or 4.2 billion years ago in the form of comets hitting the Earth, comets are still with us. Cometary debris is entering the Earth in huge quantities every single day. Hundreds of tons of cometary and meteoric debris are entering the Earth. Most of it is burnt in the atmosphere, but a significant fraction survives, right? So the question is, can we really look at this incoming, infalling material and prove our case 100%? Can we really do this? And we should do this because the consequences of the theory are so profound. So from about the end of the 1990s, Fred and I have been relentlessly pursuing all the space organizations, all the aerospace organizations, and so on, trying to get them to do a simple experiment, to put a detector into the stratosphere and to find out whether the particles that are coming in, the hundreds of tons of particles that are coming into the Earth every day, a small fraction of that could be biological, could have biological material like bacteria and viruses. And we didn't have any luck. But fortunately, in 2001, the Indian Space Research Organization, a very powerful space research organization, decided to go along with this and to conduct such an experiment. So we collaborated with the Indian Space Research Organization in 2001, sent sterilized collecting devices into the stratosphere, brought back samples, and lo and behold, we found bacteria and viruses in plenty. So these have been published in peer-reviewed journals and so on, and they have been commented on by people. They said, yes, so these have been picked up here, but maybe they are contaminants. Maybe they have been taken up in rare air currents to 50 kilometers from the Earth surface, and so it doesn't convince them. Now, that was the situation in 2001, and about 4 or 5 years ago, now this is 2016, 17, around that time, the Russians used the International Space Station, which is now going much higher. International Space Station, the ISS, orbits the Earth at 400 kilometers, not 40 or 50 kilometers, but 400 kilometers. And they swabbed the outside windows of the International Space Station 6 times and found microorganisms, living microorganisms. Now, there's still deathly silence on the part of the other space organizations on this, right? So I don't think the Americans have said anything. The Japanese are keeping their mouths shut. The Chinese have not said anything yet, but this is where we stand. On the basis of what we found in 2001 with the Indian Space Research Organization, right? And with the Russians, the estimated infall of biological material is just phenomenal into the Earth, onto the surface of the Earth, right? It's tons of this falling every single day. And so it is bound to have a very, very serious impact on life on the Earth. So why do we not spend more time and effort trying to figure out what is there in the infalling stuff? Last year, on 2019, I think, a group of international scientists went to the highest mountains in Europe and collected what was falling from the skies, from what is called the atmospheric boundary layer. And they found that there is, every single day, every square meter of the ground receives over 1 billion virus particles, 1 billion virus particles, right? And now the statement is that, oh, these must have been lofted from the ground in circulation, in air, and so on. No doubt that some of it has come from the ground. But if there is even 1,000th, 1,000,000th of that coming from space, then that is very important for us to know. There are techniques that are available to decide that, but no one has dared to do this experiment. So that's where we stand at the moment. I think there is crushing evidence that we are not alone in the universe, that the universe is teeming with microbial life, and that viruses and bacteria exist in the stratosphere, they're falling through the skies. Not all of that has come from the ground. Some, even a minute fraction, has come from space. And what is the reason for it's not being examined in the best possible ways that are possible, that we can do at the moment? That's a bizarre situation that we have at the moment. We just do not want to know that we are connected to the bigger universe. That is what is happening at the moment. And the possibility that some of the material that is coming into the Earth is the cause of pandemic diseases is a very real one. We have also written, Fred Hoyle and I have written a book analyzing historic epidemics, pandemics like the pandemic of 1918, 1919, the influenza pandemic. And we found that there was evidence there that we cannot explain in any other way except through an infall from the skies. There is, of course, person-to-person spread. There's no question about it. The virus is an infective agent, and if an individual gets the virus, multiplies the virus with, whether it's the flu virus or the coronavirus or COVID-19 is irrelevant. If the first human multiplies it and sneezes it out, then other people can get it. But all of the data on the influenza pandemic of 1918, 1919 showed that this was not the whole story. For example, the first major outbreaks of the second wave of the influenza pandemic in 1918 happened in Boston and Mumbai, India, on the same day, right? And there's no way in which one could have infected the other. It had to be just falling from the skies. Similarly, in the 1918-1919 pandemic, we recovered evidence for remote Alaskan communities to be suddenly afflicted with going down with the virus, with this influenza virus, and dying in large numbers. And of course, the remote Alaskan communities in those days could not be reached from the major cities except using dog sledges and very difficult ways of transport. So again, no way in which they could have moved from one place to another except through the air, through the infall process. So infall of microorganisms, infall of bacteria and viruses has a profoundly important societal importance and societal impact and should be examined without any delay. We have published a paper, myself and a Chinese colleague, about a year ago, saying that an international surveillance project is really important to start even now. It may be too late for COVID, but even now, to monitor the stratosphere for incoming viruses and bacteria that may be the cause of future epidemics. So before they fall to the ground, then perhaps vaccines can be produced, perhaps hospitals could be mobilized and so on, and it would have an important effect in managing future pandemics. Again, this has not been taken note of. It's been published in peer-reviewed journal and so on, but there's deathly silence on every aspect of the cosmic connection with life. We like to think that we are our own masters. That's the bottom line. Humans are supreme. Humans are the center of the universe. Humans are God's creation. So that's the story. And any challenge of that is a challenge of not just of science, as they see it, but a challenge of culture, of religion, of tradition.
So who do you think should take on this mission, or who needs to fund it, or how do you get funding to look into it all further then, Chandra? Because it's frustrating for you, isn't it?
Well, I think we've done the best we can do. We've looked at the astronomical data to begin with. We've shown that life is everywhere. microbial life is everywhere. There's no dispute that is possible, I think, at the moment. And as I think I told you earlier, we in the year 1986, I think, invented the term astrobiology for a burgeoning new discipline. We said that it's been the habit of scientists to separate subjects into different compartments, astronomy and biology. But astronomy and biology seem to be inextricably interwoven as far as we can make out now. And so there should be a combination of talents in these two areas, and there should be a new discipline of astrobiology. So this has happened. There are centers for astrobiology, but they are not looking at the most important questions that I like to have answered. And so this is a big problem, because they still wish to maintain the whole subject in a traditional situation where the Earth and life on Earth is still possibly supreme and supremely important. So I think it is essentially a cultural constraint. Culture has always impeded the progress of science. If you go back to the Middle Ages in Europe, in the Middle Ages, they were using a number system that was the Roman numerals. I think some of you remember the 1I and the V and the X's and so on. And this was written on all the crowns of the kings. Dates were given in this notation and so on. So when people came from Asia with a different number system, quite early on in sort of 900 AD, Europeans looked askance at this and said, this is an alien number system. It belongs to a savage race. The Indians are savages. They live in wherever they live. So it was resisted for about 200 years. And then finally, when in the 15th, 16th century, when mathematicians found that there was no way they can do maths without it was called the Hindu-Arabic numeral system, they adopted it. So it took 200 or 300 years before that happened. So I hope it doesn't take that long before the cultural revolution accepts the correct point of view in regard to life. But this is, I think, a very serious constraint. We don't often realize that that culture and tradition is really crippling in many ways in terms of our intellectual processes.
And especially, as you say, for Christians or other religions, how can religion and this kind of science theory kind of live alongside?
It's totally possible. I mean, there's no reason that Christian theologians should look askance at the idea of life being a cosmic phenomenon. It just makes the whole picture of life much grander, and the role of the creation certainly looks much better in a cosmic context than in a purely terrestrial context. We know, for instance, that there's no dispute now, because since 2009, there have been discoveries of what I call exoplanets, right? Planets that are in other solar systems, planets that can harbor life. The Kepler satellite, Kepler telescope has been discovering these, and the present estimate for Earth-like planets in our galaxy is over 140 billion. 140 billion places that would look exactly like the Earth. And that, I think, is the situation. You have Earth's copies of the Earth 140 billion times, and you have the situation where you're maintaining that the whole panorama of life is confined to this terra firma, which is the center of God's creation. That is just crazy, and it should be abandoned this very minute.
Kind of predicted maybe that coronavirus would kind of be arriving, or not coronavirus, but any kind of virus, as you say, could be coming in. And there was actually a comet that fell, wasn't there, in October over the northwest China. That's how I found you, because I
Okay.
Googled and
yeah, we a group of us, in fact, in 2019, before the COVID epidemic started, we wrote a paper in a scientific journal saying that we are heading for the lowest minimum in sunspot activity for 150 years, right? Now, the lowest minimum means that there is no magnetic field maintenance. Magnetic fields around the Earth are maintained by charged particles coming out from the sun, okay? And the magnetic field of the Earth, that's a huge magnetic sheath around the Earth, that in large measure protects the Earth from viruses, from electrically charged viruses entering the Earth. Now, if that protection is weakened, and it was a prediction that we made that this is going to be weakened because of the deep minimum in sunspot cycle, right? Sunspots have a sort of cyclic over many over decades and centuries, and the deepest minima are fairly rare, and we are in a deep minimum at the moment. Or about 6 months ago, or a year ago, we were in a deep minimum. So we said, watch it. We might have to do something about it. Surveillance of viruses would be important. We didn't actually predict the COVID virus, but it was something that the media have picked up and sometimes made fun of and sometimes taken seriously. Because the whole idea of COVID coming from space is regarded as being a joke, but I think it's not. I think all pandemics in the past have come from space. The original virus has come from space. The fact that most new viruses appear to surface in China and around that area is no coincidence. It's not because the Chinese live in close proximity to animals, and that's the usual story, that they are very primitive people, they live with the animals, and there's a transference from animals to humans more likely in China than elsewhere. That's not the case. What is true, we've written about this in our book, Diseases from Space in 1979, what is true beyond any doubt is that the mountain range, the Himalayas, right, the highest mountain range in the world, essentially punctures a hole in the stratosphere. It sort of goes into so any material, any stuff, viruses and small particles that come into the Earth's stratosphere, it's like a bath plug. It drains into, first of all, into east of the Himalayas, which is China. And that's the reason that we gave for saying that most of these things start off in China. Influenza pandemics start off in China. And the idea, again, is that these are recombinants of human viruses and pig viruses. And the Chinese are dirty people. They live with pigs and so on. So there's a mixture of racism, of cultural imperialism that goes with it. Sorry to be so blunt, but I think one has to face the fact. I think one of the most important reasons why panspermia has not taken off, despite the crushing evidence in many, many different directions, is that it is culturally unacceptable to Western science. We are regarded as pariahs. We are from a different culture, a different race, if you like, a different species even, and so they don't take our stories seriously. I mean, I'm not joking. I think imperialism, cultural imperialism, is very difficult to shake off. I mean, cultural imperialism in the United States has been essentially the dominance of the dollar and the hamburger and Coca-Cola, isn't it? And you control the world with those commodities. Likewise, cultural imperialism in a scientific sense is the assertion, even beyond all credible evidence, that their ideas are just superior to the ideas that prevail in the East or in the Orient or in an older culture. So this is by no means a joke. I think I have personally felt it, being a member of a non-Caucasian race, and we've had a lot of racial insults in relation to propagating panspermia, and it goes on. I think we tend to regard that all this is finished and we are completely enlightened. It's not true. It's not true in the United States with the racial disharmony that you have at the moment, right? I hate to bring those issues in, but I think facts have to be faced. Why is it that a certain set of ideas is so unpalatable despite all the evidence? If you have a scientific theory, if you make dozens of predictions ab initio, and if those predictions are fulfilled to an amazing degree of precision, as it has happened for panspermia, the natural sequence is to say that this is now no longer a hypothesis, it's no longer a theory. We've got to take it as a serious proposition, as a fact. That has not happened. I think it is high time that a paradigm shift that is long overdue is conceded. It took 150 years to concede the Earth not being the center of the universe, not being the center of the solar system. So the Copernican revolution I see in two parts. And the first part is to demote the Earth from being at the physical center of the universe. The second part is to demote the Earth from being at the center of biology, at the center of life. That second part is even more important than the first part for our future, for the future of humanity, and it has not happened. Something has to take place that would make people look at facts for what they are, not at where they came from.
It's hard to know where we're going to go from here then. Do you think
well,
in 100 years?
I think that I'm in general an optimistic person. I think the long-term future for humanity is that the truth prevails, that what is true in the world has to be conceded eventually against all odds. And this is going to happen. It may not take place in 10 years or 20 years, but in order to make progress, it has to take place. We've got to concede that there are major problems in terms of the global warming is one issue, right? If we burn fossil fuels in the way that we do, we're going to be in very serious trouble on a very short time scale. We have to live more ecologically. We got to respect all life on our planet, not regard ourselves as being supreme predators that can do anything to any life form. And we have to evolve a world system, a societal system, a societal governance that would sustain us in the next century, in the next centuries. I think that's going to happen. I think I can see big changes happening, and the change would be not sort of tiny changes, but the world of 100 years from now would be as different as the world of today is from the world of medieval times. I think that's the kind of difference that we're going to see. Right? In medieval times, we had serfdom and slavery and serfdom and so on, and we've more or less got rid of it, not entirely, but more or less got rid of it. And so that kind of difference between medieval serfdom and modern society would take us further in another jump, in another similar big jump, to a situation where you have all people, all humans, all animals living in harmony with one another and respecting each other as living forms, all part of a big cosmic living system. And this is very much a sort of Buddhist point of view. And the fact that I grew up from a Buddhist culture, I think also helps me to think along those lines.
Let's hope it goes that way, please. That would be amazing, wouldn't it?
Yeah, it would be amazing. I think we have every chance of that happening. But then there are also possibilities that are really gruesome and fearful that we have to face. We are accumulating in our nuclear arsenals of the world.
The possibility that people will continue.
We continue to accumulate these huge nuclear arsenals that can wipe out not just human life, but all life on our planet. So something has to intervene that would stop us from doing that and stop us from living in such huge disharmony across the world. I mean, conflicts across the world are just, at the moment, are almost at a peak, I think, is it not? The conflict between the rich and the poor and between the races of the world and so on. You'd have thought that in 2021, we would have gone much further in terms of enlightenment, but I think there's a long way still to go.
You think the shift of consciousness is happening within some people, as you say, they need to be a bit more open-minded?
I think in the young people that I talk to, people of your age and younger, and the youth of today, I think they are optimistic and they're aware of what's going on. They are rebellious of they rebel against the strictures of authority that are so cruel in various ways to control their actions and their thought processes. So I think it's going to happen. I think the tyranny of wealth and power has to subside. I think people are controlling the world with money, essentially, with power, and that has got to stop. I think the control should be with right ideas rather than with power to maintain ideas that are just self-seeking in terms of what they're doing and basically selfish. Essentially, I've not had students for about a decade or so. So no, I don't have, I'm connected to several universities as an honorary professor, and I go and give talks and interact with people. No, I don't have that much connection with young people, except I've got children and grandchildren are often an inspiration to me for what's going to be in 100 years' time or 50 years' time and so on. So I can see the progress in their ways of thinking really quite distinctly. And they're not taken in by all the propaganda that's being thrown out at them in various ways in the news media and so on. The news media are controlled by powerful, rich guys who have a certain message, and the message is often an imperialistic message. They want to maintain the status quo of society, and this is not going to be the way to go forward. I think we've got to be enlightened. We've got to think independently of all these other big guys who are trying to make the story in a certain direction.
Wow, it's quite heavy, isn't it? Really, it's quite a lot to go against.
What's that?
It's quite a lot to go against, isn't it?
It's a lot to go against for an individual, but I think for a whole society, it's easier. If a mob rebels against a tyranny, then that is better than a single person rebelling against a tyranny, isn't it? The mob has to rebel, mob has to rule, and the mob has to be enlightened. And what I seek to do in my own ways in writing books and giving lectures and so on is to educate the mob and to make them aware of facts that are really hard facts, and to tell them that what they are being told and they're being brainwashed is really not absolutely true and often false.
Intelligent life force out there as well?
I cannot for a moment believe that human intelligence is the pinnacle of intelligence. Intelligence seems to have evolved on the earth. And as I like to think of it, evolution is a process by which cosmic bits of information in the form of viruses are being systematically added to living forms as they develop on a planet like the Earth, right? So this process has led to human intelligence, to the intelligence that you and I recognize as being very, very high level and so on. But is it reasonable to think that we are at the top of the pile? I think not. I think there is going to be higher levels of intelligence that would essentially make the connection with the cosmos seem obvious. Now, to us, we've got to strain hard. I've had to strain hard to make this connection. I've got to struggle hard to get people to even listen to the connection with connection between us and the deep cosmos. Now, that connection would be obvious to people who had a higher level of intelligence, I think. They would recognize that they're just part of the universe, that they're part of the cosmos. So higher levels of intelligence are inevitably going to arise. We cannot be at the top. No way that we cannot be at the top. We can be at the top. I think that there's going to be development, maybe 100 years from now. We would have developments both in our intellectual capacities, in our vision, in our perception, and certainly also in our technologies. We would be able to use the techniques of DNA and genetic engineering as they develop to make new life forms, perhaps. We would be able to package all our genetic information into a little particle, perhaps like a dust particle, and then fling it out into space, and then thereby essentially colonize the universe with a copy of human species as of 3000, say, AD. And so this is going to go on. And it's going to go on until the Earth itself runs out of power, out of steam. The sun is going to eventually become a red dwarf. It's is eventually going to become a red giant. It's going to swallow the planets one by one, and we're going to come to a natural end. But other planets, other life on other planets would continue, and the process of reconstitution, rebirth would go on.
Wow, Chandra, I'm amazed. There's just so much to cover, though, isn't there? I feel like I really asked my questions, all of them, but
did I? I think I
covered so much. You really have. Thank you. And do you think, I was going to say as well, do you think there are sort of, I know we've got viruses that come that can make us ill, but obviously, is there going to be biological matter out there that can help humans? And
well, I think that is very important. We didn't cover that. I think the recent discoveries are really quite astounding, that not only are there relic viruses in our DNA, right? Our DNA came to be sequenced fully in the year 2000 with the Human Genome Project. And it came as a surprise that something like a large percentage, maybe 10, 20% of our genome is made up of relic viruses. These viruses in our past ancestry, in our past pre-human ancestry, would have caused lethal pandemics. And they are still lodged in our DNA as essentially as souvenirs of the past, or relics of the past. The connection of viruses and bacteria with humans is becoming more and more evident in the last decade. We know that bacteria and viruses around each of us constitute a microbiome. Microbiome is a word that has been coined relatively recently. It's the biological sort of cloud of, essentially cloud sometimes inside you, mostly inside you, of bacteria and viruses that are taken from the environment where you live, right? And these play a crucial role in our well-being, in our metabolism, in our functioning. For instance, I mean, the microbiome in our guts is well known for digestion and for our well-being generally. And the microbiome of the brain is supposed to be important now. Viruses are regarded as being very important in the development of consciousness. Viruses in the past have been important in the origin and development of placental mammals. If you go back in our ancestry to the time that mammals first emerged on the earth, then the involvement of viruses is almost universally accepted now. Viruses were really crucial in making the emergence possible of placental mammals. So we are not essentially, our body cells are outnumbered vastly by a microbial entity that surrounds us or goes along with us, called the microbiome. There are more microbial cells in our body that are just derived from the environment, right? And some of that would have come from space, of course, I think. And that they outnumber our body cells, our somatic cells. So that's been a realization that has been sort of relatively recent in the last 10 years or so. A virus in regard to consciousness also has been written about. I read a paper yesterday, a couple of days ago, in which they said that viruses are crucially important in the mechanism of consciousness. So it all connects with the story that we are connected. We as thinking, conscious entities are connected with the vast universe around us. A universe of microbes, of bacteria and viruses.
Thank you so much for talking to me today, Chandra. You've really taken such great time, and it's been fascinating. I could talk to you all day.
Okay, yeah. The only question that I see in your list, what advice would you offer young people living in today's age?
Yes, please. Yes, please.
Can I, let me just, okay. I want to get the right quote. The last words of Siddhartha Gautama, the Buddha, in the 5th century BC, to his disciple as his dying words, was that, be lamps unto yourselves. Look not to any other, but think for yourself. Do not rely on any other's opinion. That could be the best advice that I would give a young person. It's the best advice that I would give a research student. If I were to take one on now, I would say, do not listen to or take as 100% correct the ideas that are being presented to you as the ideas of experts. Think for yourself. Re-evaluate the facts of the world. That's the only way that you can make progress. I think so. I think the message can be put out to reach a bigger and bigger audience. And I think people are aware of this, but they're also aware of the fact that the restraining constraints that are being imposed by the various authorities is also quite severe. So people are not allowed to have exposure to these ideas much, isn't it? There's a kind of censorship that is implicit. It's not really an explicit censorship, but there is a lot of censorship
yeah, that's it. There's a lot of control out there, isn't there?
Total control, yeah, yeah. Your running countries are feeling that they are now in total control. They can use emergency powers to essentially bypass democracy, isn't it? I mean, lock people in their houses is not democratic, is it?
No.
In the past, there have been epidemics and pandemics, and people reacted instinctively. If they found people are sick in a certain area, they wouldn't go and gather in large numbers there. That was instinctive. And now we are supposed to do things because it's been ordered by the Prime Minister or the President. I think it's mad. I think pandemics come and go, and they have their lease, they have their time, and it's. I believe now that it's coming to 2 years on. It's coming close to the end of this pandemic. Hopefully, the herd immunity, natural immunity. You and I, perhaps, and lots of other people would have had mild infections with the COVID and become immune, and that's what happens in all infectious diseases, isn't it? Not everybody dies of it. Not everybody is infected. As soon as there's herd immunity, then the virus doesn't have a chance to keep spreading. Essentially everyone has got. The virus has hit everyone and hit some people more and caused illness, and at other people it's just become a sniffle for a day or two, and you don't even notice it, and you're immune to it. You've been vaccinated naturally, and I think that's what's happened more than the vaccine. This particular time is maybe dangerous in the sense that the Earth has no sort of gateway that's locked. That's magnetic field has disappeared for a while, for a year or two, but. Yeah, I think this year and the next year and the last 2-3 years is a minimum. There's sunspot cycle, right? And we're in a deep trough, and that deep trough is a risky business. So, but we're climbing out of it, and I think we climb out of the COVID as well through natural immunity, perhaps the vaccine also. But
thank you. Goodbye.